Area is an amount of surface enclosed by a closed sphere. Area is an amount of surface enclosed by a closed sphere. Okay, area means amount of surface enclosed by a closed sphere. That is called as area. For example, here, you can just see here, area help us find how much surface a floor, wall, field, or any flat surface cover, how much it can cover. It tells us amount of space inside the closed shape, inside. And the area, it's measured in square unit. If the area will be using as square unit. Perimeter means same unit. Centimeter means centimeter. Meter means meter. Here we are just coming for area means it will take the square unit. Centimeter means centimeter square. Meter means meter square. Okay. So in the chapters you must know some area formulas. Okay. For two-dimensional shape, first one is square. Okay. Area of the square is side into side. The perimeter is 4 into side. Rectangle is length into breadth. Okay. Area of the rectangle is length into breadth. If this is the length and this is the breadth. Okay. So L into B. Length into breadth is the area of rectangle. And perimeter is 2 times L plus B. Then area of the triangle of base into height. Okay. If the height is given, we'll be using of base into height. Then for perimeter means sum of all its sides. If you are adding all the sides, you'll be giving so perimeter of a triangle. For all the shapes, if you doesn't know the formula for perimeter, just add all the sides. A plus A plus A plus A. That is here if you are taking S. Okay, S plus S plus S plus S. 4S. If you are adding L plus B plus L plus B. So 2 times you will be getting L plus B. Okay, so parallelogram. So parallelogram, area of the parallelogram is base into height. So base into height, that is BH. So perimeter means sum of all the sides, sum of all the sides. Next circle, area of the circle is pi r square and the perimeter is 2 pi r. Area of semicircle is pi r square by 2. Then the perimeter is pi r plus d, including the diameter. Pi r plus d. If it's excluding the diameter means we'll be having only pi r. Okay, only pi r. So trapezium. So area of trapezium means of into h into a plus b. H is nothing but height. So A and B are parallel side. Okay, A and B are parallel side. So perimeter means sum of all sides. A quadrilateral. Okay, area of the quadrilateral is of. So D into H1 plus H2. So D is the diagonal. H1, H2 are two heights of a quadrilateral. Okay, of D into H1 plus H2. So perimeter means sum of all the sides. If it's a rhombus, so rhombus formula is of D1 into D2. If the two diagonals are given, you will be going with D1 into D2. Otherwise, if the altitude is given, height is given, you can go with side into height. Okay, now the perimeter is sum of all the sides. If you are adding all the sides, you will be getting the sum, or 4 into side. So next one is median of a triangle. Okay, what is median of a triangle? A median is the line segment joining a vertex of a triangle to the midpoint of its opposite side. Okay, vertex of a triangle to its midpoint of its opposite side. Now this line is the median. Okay, this dotted line is the median. Here AD is the median of a triangle ABC. Okay, now we have a theorem. Okay, a median of a triangle divides the triangle into two equal area. Okay, a median of a triangle divides it into two triangle with equal area. That means area of the triangle ABD is equal to area of ACD. These two it will be equal. That is a theorem. Okay, so AR means area of a triangle ABD is equal to area of the triangle ACD. Right, so now next, area of the triangle. Okay, area of the triangle of base into height we have learned. Okay, so we have different types of triangle. If it's a right angle triangle, okay, the formula is of base into height. If the height is given, okay, if it's right angle triangle, automatically this will be the height. Height is given of base into height, so direct formula. And here in this, okay, here the height is, this is the height, okay, altitude. This is inside. Okay, in a triangle we'll be having three variation. Okay, so in this case, okay, one side itself is the height of the triangle. Here height is coming inside the triangle. Height is inside the triangle. In this case, the height is outside the triangle. Okay, so where the 90-degree perpendicular only it will form the height of the triangle. Okay, this is one of the side, here inside, here outside. See the variation for everything. If it's a right angle triangle, we'll be going with the formula of base into height. If it's an equilateral triangle, okay, area of an equilateral triangle, the formula is root 3 by 4 a square. Root 3 by 4 side square, that is a square. If it's all the sides are unequal, okay, A, B, C, all the sides are different, we'll be going with Heron's formula. Okay, Heron's formula. For finding area of a scalene triangle, we'll be using a Heron's formula. The formula is area is equal to square root of S into S minus A, S minus B, S minus C. Okay, square root of S into S minus A, S minus B, S minus C. Okay. So once again, area is equal to square root of S into S minus A, S minus B, S minus C. Square root of S into S minus A, S minus B, S minus C. Okay, this is the area of scalene triangle using the Heron's formula. Here, what is S value? Okay, how will you find out S value? So S is nothing but semi-perimeter. A plus B plus C by 2. If you are adding all the sides and divide by 2, you'll be getting semi-perimeter. Okay. If the sides are given, we'll be adding all the sides divide by 2. In case if the perimeter is given, so perimeter divide by 2. That is nothing but semi-perimeter. Okay. So keep all these points in your mind. So exercise set 6.2, question number 1. Find the area of a triangle ADE. ADE triangle. For this triangle ADE, so in case we are just rotating the triangle, so we'll be having like this. Okay, now this is our base. We can just take AD as a base, and this is the height from here to here. Okay, this is the height. So height is nothing but 10. Right, so we can just use area of the triangle. Okay, area of triangle is equal to half into base into height. So now half into base is 8 into height is 10. 1 2s are 2, 4 2s are 8. So 4 into 10. Okay, 4 into 10, that is 40 centimeter square. Okay, unit is square unit. Centimeter square, we have to take it. 40 centimeter square. Second question, the parallel side of a trapezium are 40 centimeter and 20 centimeter. Parallel side. If its non-parallel sides are both equal, each being 26 centimeter. So find the area of the trapezium. Find the area of a trapezium. Okay, a trapezium means a quadrilateral in which, okay, only one pair of sides are parallel. So we have to draw the diagram. Okay, I have drawn A, B, C, D is a trapezium with one pair of opposite sides are parallel. They give given parallel sides. So parallel sides are 40 centimeter and 20 centimeter. So non-parallel sides with equal length of 26, 26. So the height is not given. Okay, height is not given. Okay, the height is given. We know the formula. Okay, area of trapezium is equal to of h into a plus b. So height is not given. So we have to find out the height. Actually, this is forming, okay, 90 degree. This is if you are drawing. Okay, join AM So BM, it will form 90 degree. So based on this, I can just find out the height. Okay, first I am going to find out the height of a trapezium. How we can find out? So total is given. Base is 40 and this is 20. Now this should be, okay, we have to take it as this is 10, correct? This is 10, correct? Then 10, 20, 10. So total will be getting 40. Now this is 10, this is 26. We can find out AM. Okay, AM we can find out. So using the Pythagoras property, okay, using the Pythagoras property, AM, that is AD square, hypotenuse square, is equal to sum of the other two sides square. So using the Pythagoras property, AD square is equal to DM square. Okay, so DM square plus AM square. Okay, AD square is given. Okay, 26 square is equal to 10 square plus AM square. So 26 square, 676. Okay, 676 is equal to 10 square, 100 plus AM square. AM square. Now just take 100 to this side. 676 minus 100 is equal to AM square. 676 minus 100 is 576. Okay, 576 is equal to AM square. Okay, therefore AM, okay, AM is equal to square root of 576. Okay, square root of 576 is 24. Okay, 24. Now AM is equal to 24. Now I got AM is equal to 24. Okay, so we have to use the formula. So area of trapezium. Okay, area of trapezium. So area of trapezium is equal to of into H into A plus B. Of H into A plus B. So A and B are parallel side. Okay, A and B are parallel side. So of into height is we found out 24. Okay, into A value, we can just take it as 40. Okay, 40 plus B value 20. A and B are parallel sides. Okay, this is 40, this is 20. Now just simplify it. Okay, now we can cancel 1 2s are here, 1 2s are 12 2s are. So 12 into 40 plus 20 is 60. Okay, so 12 into 6. Okay, 12 6 are 72. Okay, 0. 720. Okay, therefore area of the trapezium is equal to 720 centimeter square. Okay, centimeter square. Okay, so question number 3 is find the area of a triangle given that its side is 8 centimeter and 11 centimeter long and its perimeter is 32 centimeter. Okay, two sides are given and the perimeter is given. So we have to find the area of the triangle. Area of the triangle. Okay, so first of all, I'll just go with a diagram. Okay, first we'll draw the diagram. Okay, I'm just taking a triangle. So triangle. Okay, ABC we can just take, if you are just naming the triangle as ABC. Okay, so this is A, B, C triangle. Okay, in a triangle ABC, two sides are given. One is 8 centimeter, 11 centimeter. The next side is not given. So I'm just taking a C. Okay, so we know that, right? So the side we can take it as this is ABC, the side of the triangle. And here they have given the perimeter. Okay, so perimeter is given. So based on the perimeter, we have to find out the third side. After finding the third side, so we have to use Heron's formula. All the sides it will be unequal. So we'll be using Heron's formula. Okay. So now, so first you write what is given in the question. So given sides are 8 centimeter and 11 centimeter. So next perimeter is given. So perimeter is equal to 32 centimeter. Okay, 32 centimeters. So we know perimeter means sum of all the sides. Okay, perimeter means sum of all the sides. is given as 32 centimeter. So sum of all the sides. I'm just writing 8 plus 8 plus 11 plus. So third side I'm just taking a C. Okay, third side I'm just taking a C. Okay, 8 plus 11 plus C is equal to 32. Now 8 plus 11 is, we are getting 19. 19 plus C is equal to 32. Now C is equal to 32 minus 19. Okay, now C is equal to 32 minus 19, 13 centimeter. Now C is equal to 13 centimeter. So they are asking the area of the triangle. Okay, so this is height is not given and this is not an equilateral triangle. So this is an what is a scalene triangle. All the sides are unequal. So we have to use only Heron's formula. So I'm going to use Heron's formula to find the area of the triangle. Right. Now I just write area of the triangle ABC. Okay, so area of triangle ABC. So the Heron's formula, okay, Heron's formula is square root of, okay, S into S minus A, S minus B, S minus C. S into S minus A, S minus B, S minus C. So S is nothing but semi-perimeter. Okay, S is nothing but semi-perimeter. So S value I can just find out. Semi-perimeter is nothing but perimeter is given means perimeter by 2. As they get given perimeter, we can just take perimeter by 2. Otherwise, what you have to do? A plus B plus C by 2. We have to add all the sides and divide by 2. Okay, so perimeter is semi-perimeter is equal to perimeter by 2. So perimeter is given as 32. So 32 divided by 2 is equal to 16. S value is equal to 16. Now just substitute in the formula. Okay, square root of S value. Okay, 16 into 16 minus A. So I'm just taking this is A value. Okay, this is A, this is B, and this is C. Okay, A, B, C we can just interchange also. Anyway, we'll be getting the same answer. Okay, so S into S minus A. A is 8 and S minus 16 minus B value is 11. Next S 16 minus C value is 30. Okay, we can just simplify it. So 16 into 16 minus 8 is 8 into 16 minus 11 is 5 into 16 minus 13 is 3. Okay, so 16 into 8 into 5 into 3. Okay, in this case, you don't multiply everything and try to find out the square root. Okay, will not get it. Okay, don't multiply it. So instead of multiplying, okay, try to make it as a pair. So 14, 16 is a perfect square number. Okay, I can just take directly outside. Okay, 8 is not perfect square number. So try to make it as a perfect square number inside. Okay, so 16 square root will be taking us 4 outside. Okay, 6 square root of 16 is 4. I'm just taking 4 outside. Okay, now 8 can be written as 4 into 2. 4 into 2, 8 into 5 into 3. Again, 4 is a perfect square number. I can take 2 outside. Okay, already 4 is outside. Into square root of 4 is 2. I am taking 2 outside. So balance we have 2 into 5 into 3. Now 4 2s are 8 into 5 2s are 10. 10 3s are 30. Okay. So 8 root 30. 8 root 30 is the area of the triangle ABC. So area unit is centimeters given. So you can take it as centimeter square. Okay, centimeter square. Now the next question. Okay, question number 4. The side of the triangular plot are in the ratio 3 is to 5 is to 7. Its perimeter is 300 meter. So find its area. Find its area. Here they have given in the form of ratio. Okay, so I am just taking 1 is 3. Okay, so ratio means whenever its ratio is given, we have to take it as x. Okay, so now I'm just taking one of the side is 3x. Next one is 5x. Another side is 7x. Okay, A, B, C. Okay, and the perimeter is given. Okay, so given, so ratio of the side 3 is to 5 is to 7. Ratio is given, and the perimeter is given. Okay, so perimeter is equal to 300 meter. So whenever the ratio is given, so you will just take it as let the side A is equal to 3x and B is equal to 5x and C, the side C is equal to 7x. So perimeter means sum of all the sides. If you are adding all the sides, you have to get it as 300. Okay, now add all the sides. So 3x plus 5x plus 7x is equal to 300. Now 7 plus 3 is 10, so total 15. So 15x is equal to 300. Now x is equal to, so 300 divided by 15. Okay, so you're getting 2 15s are 30, 1 0. So 20. Now x is equal to 20. X is equal to 20. If it's x is equal to 20, we can find out all the sides. So now, therefore, we can just take A, we are just taking as 3x. A is equal to 3x, which means, so 3 into 20, 60. Okay, A is 60 centimeter. Next, B value. So B is given as 5x. So 5x means 5 into 20, 100, 100 centimeter. Next, C value. C is given as 7x. 7 into 20. So 140 centimeter. So A, B, C, all the sides we know. They are asking the area. Okay. Area of the triangle. Okay. Area of the triangle. Okay. Okay. So area of the triangle formula. Who? Nitin can say. Area of the triangle.
Sir,
Hmm.
half into bigger.
Hmm. Here, do you know height?
No, sir.
Then what formula has to be used?
I think we should use Heron's formula.
So we would use Heron's formula. Right. So height is not given, right? Yes, Heron's formula, Kalpana.
Root of S into S minus A, S minus B, S minus C.
Okay. Right. So here for finding the area of the triangle, we will be using Heron's formula. Okay, Heron's formula, area of the triangle. Okay, if you want to write area of the triangle ABC, we can just name it as this is A, this is B, and C. If you want to give the name, give it a name. Okay, area of the triangle. So area of a triangle. Area of triangle is equal to square root of, okay, S into S minus A, S minus B, S minus C. So first of all, I have to find out S value. Okay, S value here, perimeter is given. So perimeter is given means I can just take S is equal to, so perimeter by 2. Okay, perimeter by 2. So 300 divided by 2. So 300 divided by 2 is 150. Now S is equal to 150. Substitute in the formula. Square root of, okay, S value 150 into 150 minus A value is 60 into 150 minus B value is 100 into, so 150 minus C value is 140. Okay, simplify it. So 150, so 150 into 150 minus 60 is 90 into 150 minus 100 is 50 into 150 minus 140 is 110. Okay, so now don't multiply directly, try to make it as a pair. Okay, so we have to make it as a pair. Right, so 150 minus 140, that is 10. Okay, 10. So now we should not multiply everything. So instead of multiplying, we'll make it as a pair. Okay, 150 I can just write it as, okay, 150 can be written as 15 into 10. Okay, here one more 10 is there. So I can just take it as 10 outside. Now the same is into 90 can be written as 9 into 10. And 50 can be written as 5 into 10. Okay, into here one more 10. Okay, now so here 110, here 110. So total we have, okay, this 10, 10 we can take outside. This 10, 10 we can take it outside. Okay, so total two tens I can just take outside. First I'm just taking here 110. Okay, the 10 is outside. And from this pair I can just take 110 outside. Next, 9 is the perfect square number. Okay, 9 is a perfect square number I can take outside. That is a 3. Okay, so balance you write inside. So balance I have 15 into 5. So now we have 10 tens are 100. 100 into 3 is so 300. So 300 outside and into. So 15 can be written as again 5 into 3. Okay, 5 into 3 is 15. Again 5. So now 5 is having a pair. So just take 5 outside. So now 300 into 5. So balance we have only 3. So 5 threes are 15. Okay, 15. So now two zeros. So 1500. So into root 3. Now this is the area. Okay, area of the triangle is 1500 root 3 centimeter. Okay, meter is given. So meter square. Okay, meter square. So now here, so question number 5 is one diagonal of a rhombus is twice the long as the another diagonal. Okay, if the rhombus has the area 128 centimeters square, find the length of the shorter diagonal. Okay, so diagonal 1, diagonal 2 will be having in rhombus. Here one diagonal is twice as long as the another diagonal. So they are asking the length of shorter diagonal. Okay, so first we'll go with the diagram first. Okay, so I'm just taking a rhombus A, B, C, D. It's a rhombus with the two diagonals. One is D, another one is, okay, 2 times D. One diagonal is, okay, twice the another diagonal. So I'm just taking as 2D. Okay, now what is given? So area is given. Okay, area is given is equal to 128 centimeters square. So we know the formula for area of rhombus, that is of, okay, so D1 into D2. Okay, diagonal 1 into diagonal 2 is equal to 128 centimeters square. So now of, so D1 I am just taking as D, and D2, diagonal 2 I am just taking as 2D. Okay, 2 times the diagonal. 2D is equal to 128. So now we can just cancel. Okay, 2 get cancelled. So D into D. So D into D is D square is equal to 128. Now D is equal to a square root of 128. Okay, 128. Now they are asking find the length of the shorter diagonal. So that is nothing but D value. If you're finding D value, that is a shorter diagonal. So D value, D is equal to square root of 128. Okay, so 128, try to make it as a, okay, pair inside. So 128, how we can write? If you are not able to find it, so you have to use, so prime factorization, use it. Okay, 128. Okay, if I use 2 table, 6 twos are 12 and 4 twos are 8. Next again, 2 table, okay, 3 twos are 6 and 2 twos are 4. Next 2 table, okay, 16. Okay, 16 is a perfect square number. We can just keep as it is. Correct? Huh? Or you have to do, okay, continuously we have to do it. So 16 is a perfect square number. I'm just keeping up to this, right? So I can just write this is as 128. How we can write? 2 into 2 into 2 into 16. Right, so now here 2 is having a pair. I can just take 2 outside. Into 16 is a perfect square number. Square root of 16 is 4. I can just take 4 outside. So inside only we have 2. Okay, now 2 4s are 8. 8 root 2. Okay, 8 root 2 centimeter. Okay, 8 root 2 centimeter. This is the shortest. Okay, shortest diagonal. Okay, therefore D is equal to 8 root 2 centimeter. Okay, question number 6. So ABCD is a parallelogram. Okay, so P and Q are 2 points on the side AB. So what can you say about the ratio of a triangle BCD is to area of the triangle QCD? So diagram we have to draw first. So we have to take a parallelogram ABCD, taking a parallelogram. ABCD is a parallelogram. In that I am just taking P and Q are 2 points on the side AB. Okay, so P and Q are 2 points on the side AB. So now they are asking what can you say about the triangle? Okay, ratio of the area of the triangle BCD. Okay, so BCD. Okay, this triangle. Okay, BCD triangle is to area of the triangle QCD. Okay, so what is the ratio of these two triangle area they are asking? Okay, so for this you must know one thing. Okay, this is like a theorem. Okay, if the two triangles are having same base and lies between the same parallel lines, the areas it will be equal. Okay, theorem is not given, but in the last year they have given us a theorem. Okay, you must know the statement. If the two triangles are having the same base, for both the triangle, okay, so DC is a base. You see, both the triangle DC is a base. The two triangles are having the same base, and between the two parallel line, okay, DC is parallel to AB. Why? Because this is a parallelogram. Okay, this is a parallelogram. Correct? Having the same base between two parallel lines, right? Areas it will be equal. Areas it will be equal. That is the concept. Okay, therefore, the area of the triangle BCD is equal to area of the triangle QCD. So just mention the statement, areas are equal. Therefore, both the areas are equal. Okay, areas are equal means you can just take it as 1:1 ratio. Okay, this is one way. Okay, so another way, if you want to prove this is 1:1 ratio, we can just take it as, okay, both are having same base lies in between two parallel lines. That means the height it will be equal, correct? The height it will be equal for both the triangle. So now we can find out area of the triangle BCD. Okay, area of the triangle. They are asking the ratio. So I'm just writing. So area of a triangle. So area we can just write it as area. Okay, area of the triangle BCD. So by area of the triangle, okay, area of the triangle QCD. So the formula is of base into height. We can just take it as of, so base into height. So height is both are same. Okay, both the triangles are having the same height. Okay, now divided by here also I can just take it as of, so base into height. Now we just find out, okay, area of the triangle BCD. Okay, BCD, what is the base? Okay, of into, so base is DC. Okay, base is DC into height is same. Okay, H. Now divided by of into base of the triangle QCD. QCD triangle base is same. So DC into height also same. DC. Now we can cancel, of get cancelled, DC get cancelled, HH get cancelled. So balance we are getting as 1 by 1. Okay, 1 by 1 is nothing but the ratio is 1:1 ratio. Okay, 1:1 ratio. So just learn this statement alone. Okay, if the two triangles are having the same base between two parallel lines, so the areas are equal. Areas are equal. So now question number 7. Question number 7. So I have just taken the diagram. Okay, PQRS. Okay, PQRS is a parallelogram. In that, I'm just taking right. So the diagonal. Okay, so PR is the diagonal. PR. So PR is the diagonal, and I have to take a point O. Okay, take a point O on the diagonal. Okay, PR. So now PR is the diagonal. I'm just taking a point. O is here. Okay, I'm just taking a point O on the diagonal PR. So we have to prove that PSO, okay, PSO. So area of the triangle PSO is equal to area of the triangle PQO. Okay, so I have to prove these two triangles areas are equal. Okay, this triangle area is equal to area of this triangle. Okay, so these two areas are equal. We have to prove it. So how can we prove? Okay, we are going to apply the theorem. Okay, so let me explain. Now, so in a parallelogram PQRS, okay, so in a parallelogram PQRS, I'm just drawing the diagonal. Okay, QS. PR already diagonal we have drawn. I am just drawing. Okay, QS is the diagonal. Okay, that is intersecting. So PR at T. Okay, intersecting PR at T. Now in a triangle PSQ, okay, PSQ triangle. Just consider this big triangle PSQ triangle. Okay, now PT is the median. Okay, PT is the median. Why? Because T is the midpoint. We know that in a triangle. So in a parallelogram, diagonals are bisect each other. That means this will be a midpoint. Okay, T is the midpoint of SQ. If you are joining, okay, a line segment joining from the vertex to the midpoint is called as median. Okay, so PT is the median. We can just say PT is the median of a triangle PSQ. PT is the median means we have learned the theorem. Okay, median divides the triangle into two equal area. Correct? Median divides the triangle into two equal area. That means area of the triangle PST is equal to area of the triangle PQT. So that's only you have taken. So area of the triangle PST is equal to area of the triangle PQT. So median divides the triangle into two equal area. We have learned as a theorem. Now this is our equation number 1. Now we consider the next triangle, this triangle. Okay, in a triangle OSQ. Okay, OSQ triangle. So in this small triangle, you just consider. Now OT is the median. So OT is the median means dividing into two equal area. I can say that OST is equal to OQT. These two areas are equal. I am just taking that is second equation. So I have to prove, we have to prove this. So the area of PSO. Okay, so PSO is equal to PQO. You have to prove it. So how to prove it? Area of the big triangle minus area of this portion. Okay, we have to subtract. Okay, so equation number 1 minus 2. Okay, equation number 1 minus 2, you'll be getting, that is area of the triangle PST. Okay, PST minus, okay, area of the triangle OST. So PST minus OST, I'm getting this shaded portion. The same as area of the triangle PQT minus OQT. If you're minusing, you'll be getting the shaded portion Q, okay, PQO. So that's what we are just giving the proof. So therefore, area of the triangle PSO is equal to area of the triangle PQO. Okay, just taking big triangle and small triangle using the concept of median. Median, it will be dividing the triangle into two equal area. Okay, so area of the big triangle minus area of the small triangle will be getting area of the shaded triangle. So question number 8, if the midpoint of the side of a foreground, okay, foreground means four-sided polygon, that is called as quadrilateral. So are joined in order. So prove that the area of the parallelogram thus formed will be half of the area of the foreground. Okay, this only you have to prove it. So first we are just considering is ABCD is a quadrilateral. So inside I am just taking PQRS, one more quadrilateral. So I have to prove that is PQRS is a parallelogram, is half of the area of the quadrilateral ABCD. That's only how to prove it. Okay, prove that the area of the parallelogram will be half of the area of the given foregone. So first you got to understand what you are going to prove it. We are going to prove it. Area of the parallelogram PQRS is of the area of the quadrilateral ABCD. Hmm? Okay, so based on this, right? So directly we cannot prove it. Okay, the diagram is given. So now this is the proof. So first, okay, let the diagonal AC and BD intersect at O. I am just joining the diagonals AC and the diagonal B and D. So I am joining the diagonals. Let it intersect at, okay, let it intersect at O. Now, both the diagonals AC and BD intersecting at O. So now, what you can say? Area of the triangle ABCD. ABCD. So area of the triangle ABCD, we can just take it as area of the triangle AOB. Okay, so total area of the triangle ABCD is dividing into four triangle. I am just splitting it. Area of the triangle AOB plus BOC plus COD plus DOA. If you're adding four areas of the triangle, you'll be getting area of the quadrilateral ABCD. Okay, this part. Since, right, so PQRS is the midpoint. They have given if the midpoint of the four sides of the quadrilateral. So PQRS is the midpoint. Okay, so we can just say that area of the parallelogram PQRS. Just take area of the parallelogram PQRS. Okay, as PQRS is the midpoint in a parallelogram, area of the parallelogram PQRS, right? So in this, I'm just writing as, okay, this portion, okay, this portion. So can be written as half of the triangle AOB, okay? The same ways, this portion is half of the triangle, so OBC. And this portion is half of the triangle COD, and this portion is half of the triangle ODA. Okay, everything is off. If you are adding all this, you are getting area of the parallelogram PQRS, that is off. So now everywhere off is common. 1 by 2, 1 by 2, 1 by 2. Just take 1 by 2 is outside. What are you getting? Area of the triangle, okay, AOB. So everywhere you are getting is, okay, so off is common, just take off outside. So balance area of the triangle AOB, area of the triangle BOC, area of the triangle COD, area of the triangle DOA. Now if you are adding all this, okay, if you are adding all this is nothing but area of the triangle ABCD. Okay, ABCD. If you want to just name this as 1, okay, from 1, from here to here. Okay, I'm just writing from 1. I can write it as off into area of the triangle ABCD. So that's what we have to prove it. Question number 9. In a triangle ABC, the median of BC is D. Okay, triangle ABC. So D is the median. Next, a median AD is drawn. Okay, median AD is drawn. So P is any point on AD. So we are just taking P on any point on AD. Show that the area of the triangle ABP. Okay, ABP. So this green color is equal to area of the triangle ACB. So this red color. So we have to prove these two areas are equal. Okay, so we have learned the theorem. Okay, median of the triangles divides the triangle into two equal area. So based on the theorem, we are going to prove this concept. Okay, so let me show the answer. Okay, first, so it's given that BD is equal to DC. That means AD is the, okay, AD is the median. Okay, so they have given D is the midpoint. D is the midpoint means you can say BD is equal to DC. If a line segment joining from the vertex to the midpoint of the triangle is called as median. Okay, now this is the median. AD is the median. Since AD is the median, median divides the triangle into two equal area. From this we can say area of the triangle ABD is equal to area of the triangle ACD. Now that is our first equation. Next, again, BD is the median of a triangle BBC. Okay, in the small triangle, BD is the median. Again, BD divides the triangle into two equal area. Okay, this area. So this area is equal to this area. Actually, you have to prove green color area is equal to red color. So what do you have to do? We have to subtract. Okay, 1 minus 2. Okay, 1 minus 2. Okay, subtracting. Okay, 2 from 1 or 1 minus 2. Area of the big triangle. Okay, area of the big triangle. So minus area of the small triangle. So we'll be getting this portion. That's why we are doing it. Area of the triangle ABD minus area of the triangle BBD. In right hand side, area of the triangle ACD and area of the triangle BCD. Okay. So if I just subtracting it. Okay. Area of the triangle from a big triangle ABD. If you are just subtracting this portion, so you'll be getting ABB. The same is from the big triangle. If you are just minusing this portion, so you'll be getting this red area. Okay, this is how we are just proving. Therefore, area of the triangle ABB is equal to area of the triangle ACB. The concept is median divides the triangle into two equal area. So question number 10. So given a square ABCD. So let P be a point within it. So join BA, PD, BC, PP. Okay, join everything. So what is the ratio of area of the red region to the green region? So they are asking the area. Okay, they are asking the ratio of area of red region to the green area they are asking. So first of all, you have to find out area of the red region and green region. Then we have to find out the ratio. So both are okay. Red region we have two triangles and green region also we have two triangles. They didn't give any measurements. They didn't give any measurements. So we can just take let the side of the square be A. I am just going to take okay. Let the side of the square be A. Now this is A mean this is also A and this is also A. This is also A. The side of the square is A. So now I'm going to construct. Okay, I'm going to construct a perpendicular line. I'm going to construct a perpendicular line for this red color and this side and for green and green. Okay, I'm going to draw the height of the triangle. If you are just drawing the height of the triangles, you will be getting a diagram like this. Okay, I'm just drawing the triangle height 1, height 2, height 3, height 4. For finding the area of the triangle. So that we can just use of base into height. Correct? Now, so we can just use the formula of base into height. We are going to find out the area of red region and green region. That's it. So area of the triangle formula is of base into height. Suppose we are taking the triangle APB. So base it will be A. The height it will be H1. And for this triangle, H2 is the height. For this triangle, H3. For this, H4. Okay, now this is the concept. Now, we'll come to the solution. Okay, this is our construction, right? So let H1 be the perpendicular distance. Okay, we're just drawing the height of the triangle, H1. Next, H2 is the height of the triangle. Okay, DBC. And H3 is the height of this triangle. H4 is the height of this triangle. Okay. Now, if you are adding H1 plus H2, H1 plus H2, we are getting the side of BC. That is nothing but A value. H1 plus H2, we are getting as A. That is, they are taking as first equation. Next, H3 plus H4. If you are adding this H3 plus H4, that is also the side of the triangle, side of the square, that is A. Now, first you will find out area of triangle BAB. Okay, BAB of base into height. Okay, the same is red region. So BCD, this also of base into height. For both of and A is common. For both of A is common. I am just taking of A is outside. So balance H1 plus H2. So if you are adding H1 plus H2, that is H1 plus H2, we are getting as A. Okay. So 1 by 2, A into A is A square by 2. Okay, A square by 2. Now, area of the green region. So we have to add these two. The same as area of the triangle. Or here also for both the triangle of A is common. Just take of A is outside. H4 plus H3. H4 plus H3 is the side of the square, that is A. So A into A is A square by 2. Now they are asking the ratio. Ratio means, okay, so A to A square by 2 divided by A square by 2. The ratio. So both are same, so it will get cancelled. Okay, 1:1 ratio. So area of red region is to area of green region is equal to 1:1 ratio. Okay. So red region means two triangle we are adding. So green region we are adding these two triangles. Only the concept is, okay, we are doing the construction. Okay, we have drawing the that is height of the triangle H1, H2, H3, H4. Formula would we are using means of base into height formula. We are just using it. Can you able to understand this question? Any doubt in this? I think who is joining with Anbu Priya ID? Anbu Priya ID. I think you are in mute. Just unmute.
Sir, I'm Bhuvan, sir.
Okay, Bhuvan.
Yes, sir.
Right. Okay, still some of the cameras are off. Veda, Sri, Richard, Abdurrahman, Hashini, Saravana. Okay, any other doubts in this question? No doubts. So see, this is like one-to-one class. If you are having any doubt, you only should ask. Don't wait for others to ask. Right, it's question number 11. In a triangle ABC, okay. So D is the midpoint. Okay, D is the midpoint of the triangle AB. Okay, so D is the midpoint of AB. They have given D is the midpoint of AB is given. Okay, and P is any point on the side BC. Then Q is a point on AB such that CQ. Okay, CQ. These two are CQ is parallel to BD is given. Okay, now PQ is joined. PQ is joined. Okay, the diagram is given. So we have to prove that area of the triangle P, okay, BPQ, okay, that is BBQ, that is this is B. We have to prove BPQ. This triangle is of the area of the triangle ABC. Okay, big triangle. So actually we have to prove this triangle, this portion.
Sir, in the diagram, P is not.
ABC.
In the diagram, B is not there, sir.
This is the B.
Oh, okay, sir.
Okay, in a triangle ABC is given. Okay, so we have to prove it area of the triangle BPQ, right? BBQ. This area is equal to half of the whole triangle ABC. That's why you have to prove it. Okay. So now for proving this, so what you have to do means I'm going to do the construction. Okay, I'm going to do the consection. Okay, how we can, first of all, I'll just explain. So overall idea, how to prove it. So for proving, so I'm going to find out the area of this triangle. Okay, this triangle, area of this triangle, plus area of this triangle. Okay, so in the proof, you will get like this only. Area of this triangle, we will find out area of this triangle. And based on, okay, one property, we can just say these two areas, it will be equal. This area, you see, it will be equal to this area. So these two areas are equal. Okay, after this, we will be just saying, area of this triangle plus area of this triangle. Okay, both it will be equal. If you are adding this, this will be half of the triangle ABC. We will be proving it. Okay, for proving this, I have to do one construction. Okay, directly we will not get the answer. Okay, I'm going to draw the construction. Okay, I'm going to draw. Okay, I'm going to join C and D. Okay, join C and D. This is the construction. Okay, join C and D. Okay, I'm joining C and D. Right, so now let me show the proof. The first step, I'm just joining C and D. Okay, now since a triangle, okay, these two triangles, just consider these two triangles. So this triangle and this triangle. Okay, so this triangle and this triangle, just consider these two triangles. Okay, which two triangle? Okay, so triangle BDQ. Okay, BDQ. Sorry, not this two triangle. Okay, so we are just joining C and D. Now just consider this triangle BDQ. Okay, so this triangle BDQ and BDC. BDC. Okay, this triangle. Okay, so BDQ. Okay, we can just see the difference, right? So BDQ means this triangle. Okay, and so BDC. Okay, both are having the same base as DP. Both the triangles are having the same base DP and between two parallel lines. So we have learned if the two triangles are having the same base and between two parallel lines, so the areas are equal. Areas are equal. So that's why you can just say area of the triangle BDQ is equal to area of the triangle B. So BDQ is equal to, both are same I written now. Okay, BDC has to come. Okay, BDC has to come here. This should be BDC. Okay, once again. So now this, okay, BD is the same base for the triangle BDQ and BDC. Okay, both are having the same base as BD and lies between two parallel lines. Therefore, these two areas, it will be equal. Okay, this area is equal to this area. That is our first equation we are just taking. Okay, in the given question, D is the midpoint. Okay, D is the midpoint. Okay, if the D is the midpoint, if the line is joining from the vertex to the midpoint, we can say DC is the median of the triangle. Okay, CD is the median of the triangle. So median of the triangle divides the triangle into two equal area. So two equal area. That means area of the triangle. So two equal area means you can say area of the triangle BCD. Okay, BCD is equal to ACD. Okay, so these two areas are equal, of. Okay, so from this, right, I can just say area of the triangle BCD. Okay, BCD is going to be half of area of the triangle ABC. Okay, now if you are taking ABCD, area of the triangle BCD is will be half of, okay, area of the triangle ABC. Since CD is the median, it's dividing into 2 equal half. I can say BCD is half of a triangle area ABC. Hope you can understand. Now BCD, how we can split BCD triangle? BCD. Okay, BCD, how we are splitting? Area of the triangle BBD plus BDC. Okay, BDC. Now, so how they are taking? So area of the triangle BCD. Okay, area of the triangle BCD. So instead of this triangle, so this triangle is dividing into 2 triangles. What are the 2 triangles? One is BBD triangle plus this one. So BDC triangle. Okay. So the big triangle BCD is dividing into 2 triangles. So instead of this triangle, okay, instead of this triangle area, we already proven this triangle area is equal to this triangle. Correct? So that is from 1. So instead of area of the triangle BDC, okay, BDC, I can write it as BDQ. Okay, instead of this, I can write it as BDQ. So this is from equation number 1. Okay, equation number 1. Okay, this side we are having half of area of the triangle ABC. Now this is also half of area of the triangle ABC. Now if you are adding these 2 sides, okay, these 2 areas, BBD plus BDQ, we are getting the area of the triangle PBBQ. Okay, we are getting this triangle area. So now this is equal to half of, so area of the triangle ABC. Okay, ABC. Okay, once again, I'll just explain from the first. Okay, the diagram is given. So we have to prove, so this part, BPQ, this portion is half of the triangle, half of the area of the triangle ABC, big triangle. For proving this, I am just doing the construction. Okay, join CD. After joining CD, right, I'm just taking BC as the same base. Okay, so if you're considering BD, so BD is the same base for this triangle and this triangle. If 2 triangles are having the same base, so areas are equal. Okay, areas are equal. I'm just taking this triangle with, okay, this triangle. So BDC. So this triangle area, it will be equal to, okay, this triangle area. Okay, so now again, so BDC, that is, okay, according to the median concept. Okay, median of the triangle divides the triangle into 2 equal area. That is BDC is going to be half of the triangle ABC. So BCD, how we can write? BDC is divided into 2 triangles. One is this triangle. Okay, this is first triangle, and this is second triangle. Okay, this is first triangle, and this is second triangle. Okay, so if you are adding these 2 only, we are getting BCD triangle. So instead of this second one, okay, this also is going to be second one. Why? Because both are equal. Okay, both are equal area. So 1 plus 2, we are getting BBQ. So BBQ is half of a triangle ABC. Hope you can understand this.
Thank you for watching. Kindly like, subscribe and share. Thank you.